The National Electrical Code, specifically NEC 2020 Article 250.30, addresses the requirements for main breakers in subpanels. Understanding these regulations is critical for ensuring electrical safety and code compliance. The primary factor determining whether a main breaker is needed in a subpanel is its location relative to the main service panel. You need to install a main breaker in a subpanel if the subpanel is not located in the same building as the main service panel. If a subpanel is in a separate building, it is essentially treated as a separate service and must have its own main breaker for overcurrent protection and isolation. A critical scenario where a main breaker is required is when the subpanel is not fed directly from the service panel within the same building. Direct feeding means that the subpanel's power comes directly from the main service panel without passing through any intermediate overcurrent protection devices other than the main breaker in the service panel itself. Conversely, you do not need to install a main breaker in the subpanel if the subpanel is located in the same building as the main service panel. In this scenario, the subpanel is considered part of the same electrical system as the main service panel. Additionally, a main breaker is not required if the subpanel is fed directly from the service panel within the same building. This direct feed ensures that the main breaker in the service panel provides adequate overcurrent protection for the subpanel and its feeder conductors. If the subpanel is located in a separate building, it must have its own main breaker. This setup is crucial because the subpanel effectively becomes its own service entrance and requires independent overcurrent protection. The main breaker in this case serves to protect the subpanel and its connected circuits from overcurrents originating within the separate building's electrical system. If the subpanel is not fed directly from the service panel, it must be fed through a feeder protected by an overcurrent device such as a circuit breaker or fuse located in the main service panel. This arrangement ensures that the feeder conductors supplying the subpanel are adequately protected against overcurrents regardless of the subpanel's location. The purpose of a main breaker in a subpanel is twofold. Firstly, it protects the subpanel and its feeder conductors from overcurrents, such as short circuits and overload. This protection helps to prevent damage to the electrical system and reduces the risk of fire. Secondly, the main breaker allows for safe isolation of the subpanel from the main service panel for maintenance or troubleshooting. By turning off the main breaker in the subpanel, electricians can safely work on the subpanel and its connected circuits without the risk of electrical shock. Understanding the location of the subpanel relative to the main service panel and whether the subpanel is fed directly from the service panel will dictate whether or not you need a main breaker. Always consult the NEC and local electrical codes and engage a qualified electrician to ensure compliance and safety in all electrical installations. Always ensure the subpanel is properly grounded and bonded following NEC Article 250 guidelines. Proper grounding and bonding create a low impedance path for fault current, which helps to quickly trip over current protection devices and minimize the risk of electrical shock. Size the feeder conductors supplying the subpanel appropriately, based on the load demand of the subpanel and the ampacity of the conductors, consulting NEC Table 310.16 for ampacity ratings. Using undersized conductors can lead to overheating, voltage drop, and potentially fire hazards. Install overcurrent protection devices such as circuit breakers or fuses with appropriate ampacity ratings to protect the feeder conductors and the subpanel itself, based on NEC Article 240 requirements. Overcurrent protection devices should be sized to protect the conductors they supply without exceeding the conductor's ampacity rating. Label the subpanel clearly, indicating its purpose and the circuits it serves. Proper labeling helps to prevent confusion and facilitates easy identification of circuits during maintenance or troubleshooting. Ensure that all electrical connections within the subpanel are tight and secure. Loose connections can cause arcing, overheating, and potentially fire hazards. Regularly inspect the subpanel for any signs of damage such as corrosion, loose connections, or damaged insulation. Addressing any issues promptly can help to prevent more serious problems from developing. Consider using surge protection devices at the subpanel to protect sensitive electronic equipment from voltage spikes and surges. Surge protection devices can help to extend the lifespan of electronic equipment and prevent damage from transient voltage events. Maintain adequate clearance around the subpanel to allow for safe access and ventilation following NEC Article 110.26 requirements. Clearances should be sufficient to allow electricians to safely work on the subpanel without obstruction. If the subpanel is located in a damp or wet location, use appropriate enclosures and fittings that are rated for the environment. This will help to protect the subpanel from moisture damage and corrosion. When working on electrical systems, always de-energize the circuit before starting any work and verify that the circuit is de-energized using a reliable voltage tester. This is the most important safety precaution to prevent electrical shock. Wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools, when working on electrical systems. PPE can help to protect against electrical shock, arc flash, and other hazards. Follow lockout/tagout procedures to ensure that the circuit remains de-energized while work is being performed. Lockout/tagout procedures involve placing a lock and tag on the circuit breaker or disconnect switch to prevent it from being accidentally re-energized. If you are not comfortable working on electrical systems, hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to do the job safely. Consider future expansion when planning the electrical system. Ensure that the subpanel has sufficient capacity to accommodate future loads and install additional conduit or wiring as needed. Proper planning can help to avoid costly and time-consuming upgrades in the future. Document all electrical work that is performed, including wiring diagrams, circuit schedules, and equipment specifications. Accurate documentation is essential for future maintenance, troubleshooting, and modifications to the electrical system. When selecting a subpanel, choose one that is appropriately sized for the anticipated load and has sufficient spare capacity for future expansion. Overloading a subpanel can lead to overheating, voltage drop, and potentially fire hazards. Use appropriately sized conductors for all branch circuits within the subpanel based on the load demand and the ampacity of the conductors. Refer to NEC Table 310.16 for ampacity ratings and consider directing factors for ambient temperature and the number of conductors in a raceway. Install ground fault circuit interrupter protection for circuits serving wet locations such as bathrooms, kitchens, and outdoor areas. Ground fault circuit interrupters can help to prevent electrical shock by detecting small ground faults and quickly interrupting the circuit. Arc fault circuit interrupter protection is required for branch circuits supplying dwelling unit bedrooms, living rooms, and other areas. Arc fault circuit interrupters can help to prevent fires by detecting arc faults, which are a common cause of electrical fires. Use appropriately rated electrical boxes and fittings for all wiring connections within the subpanel. Electrical boxes and fittings should be rated for the environment in which they are installed and should be large enough to accommodate the wiring. Support all wiring properly using cable ties, straps, or other approved methods. Proper support helps to prevent damage to the wiring and ensures that it is securely held in place. Avoid running wiring through areas where it could be damaged, such as sharp edges, high traffic areas, or areas where it could be exposed to moisture or chemicals. Use conduit or other protective measures to protect wiring in these areas. Ensure that all unused openings in the subpanel are properly closed off with knockouts or other approved methods. This helps to prevent the entry of dust, moisture, and other contaminants, and reduces the risk of electrical shock. When making wiring connections, use appropriate crimping tools and connectors to ensure that the connections are tight and secure. Loose connections can cause arcing, overheating, and potentially fire hazards. Inspect all wiring connections carefully after they are made to ensure that they are properly installed and that there are no loose strands of wire. A thorough inspection can help to identify and correct potential problems before they cause a failure. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician or electrical engineer. They can provide guidance and assistance to ensure that the installation is safe and code compliant. Regularly test ground fault circuit interrupters and arc fault circuit interrupters to ensure that they are functioning properly. Testing should be performed according to the manufacturer's instructions. Keep a record of all electrical work that is performed, including the date, description of the work, and the name of the person who performed the work. This record can be helpful for future maintenance, troubleshooting, and modifications to the electrical system. When making changes to the electrical system, always ensure that the changes are code compliant and that they do not overload the existing system. Overloading the electrical system can lead to overheating, voltage drop, and potentially fire hazards. Consider the use of energy-efficient lighting and appliances to reduce the load on the electrical system and save energy. Energy-efficient products can help to lower electricity bills and reduce the environmental impact of the electrical system. Install occupancy sensors or timers to control lighting in areas that are not frequently used. Occupancy sensors and timers can help to save energy by turning off lights when they are not needed. Use a whole house surge protector to protect the entire electrical system from voltage spikes and surges. Whole house surge protectors can help to extend the lifespan of electronic equipment and prevent damage from transient voltage events. Consider the installation of a backup generator to provide power during power outages. Backup generators can provide essential power for lighting, heating, and other critical loads during emergencies. Ensure that the backup generator is properly installed and maintained, and that it is connected to the electrical system through a transfer switch. A transfer switch prevents the generator from backfeeding into the utility grid, which can be dangerous. If you have any questions or concerns about the electrical system, consult with a qualified electrician or electrical engineer. They can provide expert advice and assistance to ensure that the electrical system is safe and reliable. Always follow all applicable electrical codes and regulations when performing any electrical work. Electrical codes and regulations are designed to protect people and property from electrical hazards. Never attempt to perform electrical work if you are not qualified to do so. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to do the job safely. Remember that electrical safety is everyone's responsibility. By following these guidelines, you can help to ensure that the electrical system is safe and reliable. Regularly inspect electrical cords and plugs for damage. Replace any damaged cords or plugs immediately. Avoid overloading electrical outlets or extension cords. Overloading can cause overheating and potentially fire hazards. Keep electrical appliances and cords away from water. Water can conduct electricity and create a shock hazard. Never use electrical appliances in the bathtub or shower. The risk of electric shock is extremely high in these areas. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical hazards. Install tamper-resistant outlets in areas where children are present. Tamper-resistant outlets help to prevent children from inserting objects into the outlets. Use ground fault circuit interrupter protection for all outlets in bathrooms, kitchens, and outdoor areas. Ground fault circuit interrupters can help to prevent electrical shock by detecting small ground faults and quickly interrupting the circuit. Test ground fault circuit interrupters monthly to ensure that they are functioning properly. Follow the manufacturer's instructions for testing. If a ground fault circuit interrupter trips, do not simply reset it without investigating the cause. There may be a ground fault that needs to be repaired. If you are unsure about how to investigate a ground fault, consult with a qualified electrician. Never use a damaged electrical appliance. If an appliance is damaged, have it repaired or replaced. Never attempt to repair electrical appliances yourself unless you are qualified to do so. Always unplug electrical appliances before cleaning them. This will prevent accidental electric shock. Never pull on the electrical cord to unplug an appliance. This can damage the cord and create a shock hazard. Always grasp the plug firmly when unplugging an appliance. Use extension cords only when necessary. Avoid using extension cords as a permanent wiring solution. Choose extension cords that are rated for the intended use. Do not use extension cords that are frayed or damaged. Avoid running extension cords under rugs or furniture. This can damage the cord and create a fire hazard. Do not overload extension cords with too many appliances. Overloading can cause overheating and potentially fire hazards. Keep extension cords out of reach of children. Children can trip over extension cords or insert objects into the outlets. Store extension cords properly when they are not in use. Avoid kinking or twisting the cords, which can damage them. Inspect extension cords regularly for damage. Replace any damaged cords immediately. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical inspector. They can provide expert advice and assistance to ensure that your home is safe from electrical hazards.